So again, our thunderstorm forms when you have warm, moist air, unstable, rises up, whether it's due to convection, going over a mountain, or a cooler air mass that it's pushed up over. As the air rises, it's under less pressure, it expands, lower pressure, cooling, adiabatic, and we hit the dew point, and we start to build clouds, puffy cumulus clouds. As the water condenses, it's releasing the latent heat of vaporization, and that keeps our air from cooling off. And this promotes rising air. We get an updraft. Okay, so that updraft, rising air, that will be key to making our thunderstorm. Here are examples. Here's a front, and the storm's coming along behind that. Here's a big piled up summer cumulus cloud. Updraft, we pile up our puffy cumulus clouds. As that keeps rising, we get freezing, we start to make ice crystals, snowflakes. But we've got that strong wind blowing up. So they keep on rising and get more water sticking to them, freezing on. They grow. Eventually, if they get heavy enough, they will start to fall. Depending on the temperatures beneath, they may melt and form rain. As they're falling though, friction with air, they're pulling air with them. So you get downdraft of air moving down along with that updraft moving up. But also as rain falls, rain's typically cooler. So that rain's going to be cooling down the ground under the storm. But the storm formed because of rising warm air. Now we're cooling it off. So thunderstorms do tend to kind of rain themselves out over a relatively short period of time. So here are pictures of that. Here we have warm, moist air rising, great big puffy cumulus cloud. That's a good sign to make sure you know where your umbrella or some shelter is. As the storm develops, you've got the rising air, but also falling downdrafts as the falling ice and raindrops bring air down with it. And again, eventually that cools the ground underneath. We no longer have the rising air, but we still have falling as the storm is dissipating, breaking up. Okay, what are the dangers associated with a thunderstorm? What are the hazards there? Yes, one of them will shock you. Heavy rain, and with that the associated flooding. We can also have hail, large chunks of ice falling. That can be quite damaging. Strong winds associated with the storms. Lightning, the updrafts and downdrafts can separate electric charges and lead to giant sparks of lightning. And thunderstorms also are what produce tornadoes. So again, basic idea, we've got the rising air, updraft, falling stuff, downdraft, and precipitation. And these can build up different electric charges on the stuff moving up and down and separate stuff with positive and negative charge. And eventually, when those build up to strong enough charges, air's a pretty good insulator, but it's got its limits. And so you get a giant spark, known as lightning. It's the same idea as a spark you can get with scuffing across a rug on a winter day and then reaching out towards a metal surface or a friend or whatever and zapping it. Just much bigger for lightning. Lightning can be within one cloud, between different clouds, or between the cloud and the ground. We're usually on the ground rather than in the clouds, and so the cloud to ground or ground to cloud is what's generally a potential problem for us. Updrafts are also why you potentially get hail. Hail is a form of frozen precipitation. Basically, as you have rising air, if the air is blowing vertically strong enough, it can carry a bit of ice up, and it gets more and more layers of ice built up on it as it keeps on blowing until it finally gets heavy enough to fall. Now, most hail is rather small, like a BB or P. They can get up to softball size. Of course, the ones that get posted on the internet are usually big ones. Usually it's pretty small, under 2 centimeters. So here are examples. Again, pretty obviously, you would not want chunks of ice like that falling on you. When, again, our buildup of ice gets too big, too heavy for the updraft to carry, then it's going to fall. So really big hail tells us we've got a very strong updraft. There are strong winds up there. Stronger winds, more severe storm. And that can potentially generate a tornado, or also strong straight line winds. Not all damaging thunderstorm winds are the rotation of a tornado. You can get very strong damaging winds that are going in a single direction. Lightning. What are the problems here? Turns out that a relatively tall, pointy structure tends to concentrate the electric charges on the tip, and that makes them likely to get struck. Now, if you are inside a metal structure, electric charge will stay on the outside of a metal structure, so inside your safe, such as in a car. You can find videos online if you search of car getting struck by lightning and car keeps on driving. Inside a building is the safest spot to avoid getting hit by lightning. Inside a car is pretty good as well. If you are stuck outside, then the best thing to do is to crouch down as low as you can get. Now, crouching down, why that? You could get lower by lying down, but there are certain problems. One thing, if you are lying down and lightning strikes the ground, that's not good. You get pretty well zapped. But when you're crouched but still standing, then that little area of your feet, that's not a very long distance for the electricity, so you don't get as big a current going through you. And you're kind of a dead end, not the greatest way for the electricity to go. Similar to why a bird can perch on the power line. But if you can touch 2 power lines, you're in trouble. Of course, also, you want to try to be relatively low, not on top of a hill, but down in a ditch is not good. What was the first hazard of thunderstorms listed? Heavy rain and flooding. Lie down in a ditch. Yeah, if you don't get zapped by lightning but you drown, that's still bad. So you want to crouch down in a low area, but not down in a ditch, and don't lie down on the ground. Open area. The tallest point in this field, right there. So out in an open area, that is not a good place to be during a storm. Again, lying down, you get zapped if the ground is hit. Too low, you don't want to get flooded. Okay, from thunderstorms, one possible very severe side effect is generating tornadoes. Tornadoes are very small as weather phenomena go, but very, very violent, extremely powerful winds. Funnel-like pattern. They can be 100 meters, 400 meters or more across, and the winds are blowing very fast, over 300 kilometers an hour at least. Across the ground, a tornado may be moving at 50 kilometers per hour or more. You can potentially sprint that fast. If you are having to run away from a tornado, what you want to do is run sideways the direction the tornado is going to get away from it. Better to use your car to get away from it, but you could potentially run away if you're, instead of running with the tornado coming after you, run sideways to the tornado. Tornado is a cyclonic system, very low pressure on the inside, and that with the very strong winds leads to the damage caused. Tornadoes are most common in the central U.S., area known as Tornado Alley, Texas up through Oklahoma, Kansas, Iowa, Nebraska region there. Turns out the U.S. does have more tornadoes than anywhere else in the world, at least as far as we know. Again, tornadoes are rather small systems, so if nobody is there to see it, well, we don't know that happened. So the total occurrence of tornadoes is something of a question, but from the tornadoes that we know, the largest number are indeed here in the U.S. So a tornado is officially defined as a very rapidly rotating body of air associated with strong thunderstorms that reaches down to the ground. A little problem there. What happens if a tornado hops? Well, it wasn't on the ground just then. Is it not then the same tornado? Yeah, where you draw the line is a challenge there on the definition. Not surprisingly, these are very challenging to study and measure. One of the first ideas of how to study them, there were reports of tornadoes blowing through a farm and taking the feathers off of the chickens. How fast a wind does it take to blow the feathers off a chicken? And this was noticed back in the 1800s. So 1842, there's a fellow thinking about tornadoes in the Midwestern U.S. and wondering how to study this. How can you try to see what wind could take feathers off a chicken in 1842? Well, conveniently, the town had an old Revolutionary War cannon out in the square. And so he put powder in the cannon, put in a chicken, hopefully already dead, and fired it off. And yeah, feathers went everywhere. But there are certain problems with this experiment, and we're not going to be doing that in lab. For one thing, it was a little hard to tell how much the damage to the chicken was from the explosion of the gunpowder versus how fast it was moving through the air. A difficulty there. Also, there's the issue of, is taking chickens off of feathers, or feathers off chickens, always the same amount of effort. Turns out that when chickens are particularly scared, they can, to some degree, let up on the grip they have on their feathers. This is useful, say, if there's a predator, if they're being chased, say, by a fox, and a fox bites and gets a mouthful of the feathers, chicken can let go of the feathers and run off, and the fox has just got feathers. This does not work to discourage a tornado, but the chicken's scared. It may have the same response and somewhat let loose its grip on the feathers. And so how easy it is to pluck a chicken is not a good fixed measurement. So how about today? People are not shooting chickens out of cannons to try to measure tornadoes anymore, but they are still very challenging to study and measure. The link there, if you click on it, that has a bit on a project to measure weather in our part of the world. So maybe you're interested in taking a look there. Some very strong weather measurements have been designed in order to try to get a measurement of what's going on in the tornadoes, but there are still problems associated with them. What will be a challenge here? Well, one, how do you get your measuring device to the tornado? This one here, they called it the Totable Tornado Observatory, so they could use the acronym of TOTO, like Dorothy's dog. Only problem was they never managed to get one of those into a tornado. Again, tornadoes are relatively small systems. And so, I mean, in principle, if you made millions of these and covered Kansas with them, you could be reasonably confident that a tornado would hit one of them, but that's not a very practical approach. So, getting your measuring device to a tornado is a challenge. Now, you do have those crazy folks running around trying to chase storms, and so you might be able to get one of them to volunteer to take one of these and run out and toss it in front of a tornado that's coming and run away again. That might potentially work, but there is a definite risk there. The fellow who designed this one has chased his last storm. It caught it. So there are some distinct risks involved in trying to study a tornado. And of course, tornadoes are powerful. Will your device actually hold up? This one here was called a Dillo-Cam because they thought it looked kind of like an armadillo. So it had a camera for taking pictures, audio recording, getting a video there, wind sensor, stuff like that. Actually managed to get one of those where a tornado ran over it. And basically the first thing the tornado did was break the cover over the camera. So you've got this great recording of terrifying tornado wind sounds with pictures of mud. Not the greatest video. So this is quite challenging. It actually is a little funny reading weather information on this sort of thing. In case of a tornado, you should head immediately to shelter. But if instead you hang out and take pictures, we'd love to see them. I recommend they take shelter rather than take pictures to send in to the Weather Service. So today, you hear about tornadoes with the first F scale, now EF, Fujimura for the name of the guy developing it, and enhanced, it's been modified some. But we're actually basing that on damage. We don't have actual wind speed measurements for most tornadoes, and so it's just a matter of trying to figure out what wind speed would do a certain amount of damage.